Okay, in this video we're going to look at question 10. Question 10 is about photoelectric effect. So the question says two small spheres A and B made of pure zinc are at rest 0.1 meter apart on a wooden table. Sphere A is negatively charged and is free to move on the table, while sphere B is uncharged and fixed to the table as shown in the diagram below. So what we have here, we have two spheres, A and B. So we have two spheres, A and B, and then made of pure zinc. And then they're saying they are at rest 0.1 meter apart on a wooden table, and then sphere A is negatively charged. So sphere A is negatively charged and is free to move. So free to move on a table, while sphere B is uncharged, is neutral, and is fixed to the table as shown in the diagram below. The high intensity, so high intensity ultraviolet light of a frequency 2.8 to the times 10 to the power of 16 Hertz is now shown continuously on sphere B. And they're saying that the work function of the zinc metal is 6.63 times 10 to the power of negative 19. So I'm just gonna analyze the information given and then explain what is happening in this question. So let's look at first what we have here. We have two spheres. We have two spheres, A and B. So this is A here and B. So A is negatively charged. So this is sphere A and is negatively charged, whereas B is positively charged. Or not positively charged, but neutral. So neutral simply means that the number of electrons is equals to the number of protons. So what you have here, you have a light source here. You have a light source. This is the light source. Okay, so with the light source here, you have a light source, and the light is shown on sphere B. Sphere B, so this is sphere B here. So when the light is shown, we know that light is made up of what? Particles. So we know that those particles, we call them photons. So when you use light on sphere B, is gonna eject what? It's gonna eject electrons, and then the electrons will move from sphere B to sphere A. So the electrons will move from sphere A to sphere B. So what we use here is that each particle of light, it carries energy, and then that energy, we say that the energy of light is HF, or if you are given wavelength, the energy of light is HC over the wavelength. So, but we know that the energy of light is transferred to electrons, and then electrons are ejected from sphere B to sphere A. So when the electrons are ejected, now because sphere B is neutral, when it loses electrons, it's gonna become what? Positive. So when it loses electrons, it's gonna become positively charged. So it becomes positively charged, and then it's gonna attract sphere A. So there will be a force of attraction. Remember, sphere B is fixed, it cannot move, but sphere A can move. So sphere A will now have a force of attraction and then be attracted to sphere B. Okay, so that is the whole concept of what is happening in this question. So let's look at now the questions. The first question says 10.1.1. Define the term work function of a metal. So what is a work function? 10.1.1. So work function is the minimum energy needed or required to eject or emit electrons. So work function, we use W with a subscript O, and then we know that work function is the minimum energy required or needed to eject or emit electrons, eject or emit electrons from the metal surface. So each metal surface or each metal carries a different work function. So in this case, the metal surface that we are using is made up of zinc, right? So it will have a different work function. So that is 10.1.1. And then 10.1.2, explain using a suitable calculation why the ultraviolet light shown on sphere B will eject electrons from its surface. So the minimum energy required to eject electron from sphere B, that energy is work function, which is given as what? 6.63 times 10 to the power of negative 19. So we want to check that the energy of the light, is it the same as work function, or is it more than work function, or is it less than work function? So we have to calculate the energy of this light. So we know that energy of light is E equals to HF, or is E equals to HC over wavelength. So in this question, we already have the frequency. So if we have the frequency, we're going to use the first equation, which is energy is HF. So H is the Planck's constant, which is given as 6.63 times 10 to the power of negative 34. This is a constant. And F, we have F in our question. It says the intensity, high intensity ultraviolet light of frequency 2.8. So the frequency here is given as 2.8. 2.8 times 10 to the power of 16 Hertz. So when you use your calculator to get the answer here, it's going to be 6.63 times 10 to the power of negative 34 multiplied by 2.8 times 10 to the power of 16. So this gives you answer of 1.86 times 10 to the power of negative 17 joules. So this is the energy of light that we are using here, which is the ultraviolet light. So if this is the energy of light, so we want to see when we compare it with the work function of zinc, is it more or is it less? So when you look at the work function, the area of zinc is what? Is given as 6.63 times 10 to the power of negative 19. So you can easily see that here, because of to the power of 19, to the power of negative 17 is more than to the power of negative 19. So in this case, the energy of light is greater than the work function. Hence, the electrons will be ejected. Because remember, the work function is the energy needed or required to eject or emit electrons from the metal surface. So if the energy is less than the work function, the electrons will not be emitted or ejected. If the energy of light is greater than the work function, the electrons will be ejected. So this is the answer that, okay, this is the reason for the electrons to be ejected is because the energy of the light is greater than the energy than the work function, which is the minimum energy. The work function. So this energy here, this is the one that you're talking about, E, and then the work function is WO. So this is the energy required for that. So that is 10.1.2. Then 10.1.3, so I'm gonna erase this for space, but I'm gonna write the answers first. So for 10.1.2, the energy of the light, we got it as 6.63 times 10 to the power of negative 17 joules. Okay, so let me erase this to create space. Okay, so with this now, 10.1.3, we need 10.1.3. It says sphere A carries a charge. So sphere A carries a charge. It carries a charge of negative 5.4 times 10 to the power of negative 6 coulomb. And it requires a minimum force. It requires a force of 0.027 Newton to move from rest. Calculate the minimum number of photons. Minimum number of photons of ultraviolet light that must strike sphere B, which will cause sphere A to move from its rest position. So remember we said that because sphere A is negatively charged and sphere B is neutral, when you shine a light on sphere B, the electrons will be ejected, and then it will now go from being neutral to being positively charged because the electrons will leave, and then the number of protons will now be more than the number of electrons. In that case, it will cause the sphere B to be positively charged. And then if sphere B is positively charged, it's gonna attract sphere A because they are unlike charges, so they will attract. So in this case, sphere A will be attracted with the force of 0.027 Newton. So we want to know how much of how the minimum number of photons required to cause this scenario here. So what you're going to do here is to now first, because we have the charge, we now have the charge of sphere A. So we have the charge of sphere A, which is negative 5.4 times 10 to the power of 6, and then B, the sphere B, which is positively charged. We don't know the charge. We don't know the charge here, but we can get that charge. But we know the distance between these two is what? We know the distance is 0.1 meters, and we know the force between them, which is the force of attraction. The force between the two is 0.027 newtons. So we can get the charge of sphere B using Coulomb's law. We're using Coulomb's law. Coulomb's law says that a force of attraction or repulsion is going to be the Coulomb's constant and then products of the charges. So sphere A and sphere B divide by the distance between them, the square of distance between them. So we know that the charge or the Coulomb's constant is that would be 9. That would be 9. The Coulomb's constant is 9 times 10 to the power of positive 9. So that is that. So we're gonna say 9 times 10 to the power of positive 9. And then charge A is 5.4. Charge of sphere A is 5.4 times 10 to the power of 6. And then we don't know charge of B. But we know that the force between them is 0.027 newtons. And then we know the distance between them is 0.1 meters. And then we square that. So if you are looking for the charge here, you can simply say that the charge of B is going to be 0.027 multiplied by 0.01 squared, and then divide everything by 9 multiplied by 10 to the power of 9, and 5.4 times 10 to the power of 6. So when you do that, we just rearrange the formula there to make charge B to be the subject of the formula. So when you put that in your calculator, you have the answer for the charge of B, so which is 0.027 multiplied by 0.1 squared, and you have 9 times 10 to the power of 9, and then you have 5.4 times 10 times 10 to the power of 6. So the answer here, if you put that in scientific notation, is going to be 5.56 times 10 to the power of, let me check here, that will be 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is to the power of -9. Okay, so that is, yeah, -9 Coulomb. So that is the charge of sphere B. So once you have the charge of sphere B, now you're gonna use this formula here. We know that the number of electrons is equals to the charge divided by the charge of an electron. So once you have these two, the charge of B in this case, we got it as 5.56 times 10 to the power of -9 divided by the charge of an electron. Charge of an electron should be in your formula sheet, which is in this case, charge of an electron is -1.6 times 10 to the power of -19. So that is the charge of an electron. So we put it there, that is 1.16 times 10 to the power of -19. So when you put that in your calculator, 5.56 times 10 to the power of -9 divided by 1.6 times 10 to the power of -19, that gives you 3.48 times 10 to the power of 10. So that is the number of electrons. So this is the number of electrons. So we know that each photon from the light source is going to eject one electron. So one photon transfers its energy to the electron, and then the electron is ejected. So each electron, the number of electrons is equals to the number of photons shown on the light. Number of electrons ejected is equal to the number of photons shown on the surface, metal surface. So in this case, therefore, the number of photons will be the same as number of electrons, which is 3.48 times 10 to the power of 10. That is the number of photons shown on sphere B. Okay, so that is the answer for question 10.1.3.